Good morning, everybody. Jim Cusack here, sitting in for Jim Strandland for this month's episode of TechTime. We're going to talk a little bit about kind of some hydronic control stuff that I've seen out in the field, and we're going to talk a little bit about outdoor reset. So let's see. I don't know why I try this again. Sorry, guys. First time I've done this. There we go. All right. So getting the most from the webinar. Don't be afraid to take a few notes. We'll take some questions at the end. You can sign up for webinar reminders on the website that's listed below. And we're going to keep this thing short, 10-15 minutes at the most. And of course, we're always here to help if you've got further questions. Again, my name's Jim Cusack. I'm the Special Projects Manager for Enertech. And you can reach me at jim.cusack, C-U-S-A-C-K, at enertechgo.com. You can always get a hold of me through Design Services also, which is Design Services at enertechusa.com. TechTime is hosted by Enertech University and Enertech Energy and Technology. Here's our technical support services team. Jim Strandland, who's normally your presenter. John Pendleton is our senior trainer and also takes tech calls. Kip Westrom, Rob Shawless, and Kerwin Wildhaber, of course, are always there when you guys need help. I'm just going to jump, excuse me, I'm going to jump right into this, and we're going to talk today about hydronics and hydronic performance of the hydronic water-to-water geothermal heat pumps. So, you know, for many years, a lot of guys have done single set point buffer tank controllers. And unfortunately, a lot of guys will set those things up to, you know, 100 or 105 degrees. I've seen some of them set up as high as 115, 120. Okay. The problem with that is that if we, hopefully most radiant floor designs, number one, don't need water temperatures that are that high. Like a well-designed radiant floor system can be designed with water temperatures as low as 80 or 85 degrees, even on peak days. And a lot of times that can be accomplished by tightening up your tube spacing a little bit. So originally, when there was a lot of radiant floors going in, I remember 20 years ago when using PEX tubing and doing radiant floors was becoming extremely popular in the Midwest where I'm from. You know, we were on a learning curve about floor insulation and some of those things. So, you know, doing a good job of insulating and doing thermal breaks anywhere that the radiant slabs are coming in contact with either the footing or a poured exterior wall can really reduce the water temperatures required to heat the space. And so as system designers, typically we always want to take a look at that, make sure that the builders or who's ever in charge of doing the insulation and or just thermal breaks in the concrete slab do a good job. And that way we're able to reduce our water temperatures. And so the chart that I've got here is showing across the bottom is the temperature difference between the loop field and the water we're trying to produce for the radiant floor. So in many cases, I'll give you my own home as an example. We can look at, I only need if my loop field is 50 degrees and I only need 80-degree water to heat my house, I only need a 30-degree temperature differential in between the loop and the load. And so, the loop and the load. And so I can see a coefficient or a COP that's up over 5. Okay. And as it gets colder out, the loop field gets colder, we start to slide down this scale and we lose our COP. Excuse me. One of the other things that I want everybody to kind of be aware of is this is the compressor envelope for the refrigeration circuit. And this is in all of our installation manuals on any of our water to waters that come equipped with a scroll compressor. And we really want to be careful looking at a 30-degree loop field temperature. Looking at a 30-degree loop field temperature. And if we've got our temperature set at 120 or above, we could very possibly be putting our compressor in jeopardy. So we're running outside of the envelope for that unit. If we keep our water temperatures lower, we really reduce the risk, and we can operate the equipment really in the acceptable operating conditions. The compressors run a lot easier. They're going to last a lot longer, and you're going to get much better efficiencies. This is a system that we have that has outdoor reset built into it on the Hydro Connect controls. And this particular system is set up to do like a radiant floor heating system and like a chilled water fan coil system. And so it's got easy connections. Everything across the bottom of this diagram is labeled, and it has the ability to lock out the radiant floor system anytime we're doing chilled water. I've got a frog in my throat. I'm sorry, guys. The HBX Eco 550 is set up if you have a heat-only system. And now what these control systems do for you is they look at the outdoor air temperature and they vary the temperature of the water in the buffer tank depending upon the outdoor air temperature. So for example, if it's 40 degrees outside or 30 degrees outside, you may only need 80-degree water to keep the space warm, which increases the COP of the system, and it allows the compressor to run a lot easier. If it drops to 0 outside and you need 95-degree water, then this controller will automatically bring up those water temperatures so that you can meet the demand of the load on the building. It's pretty hard to talk at length about hydronic system design in a short webinar like this, but if you need further assistance, the design service team is always available. I can be contacted directly, and we can help walk you through any questions that you have on system design and trying to make your systems perform more efficiently. Now, for a lot of people, there's a lot of guys in the past have used a single set point controller to do a hot tank setup where the buffer tank maintains a fixed set point temperature regardless of the call. One of the things a person can do to make that system a little more efficient is change it from a hot tank to a demand control, which means, excuse me, which means the system will only operate when there's a call for heat. So the heat pump's only going to run when there's a call. So there's a schematic here that I'll show you in a second that there's a very simple 2-wire way to fix that in many cases. Now, last week, Jim talked about sensors, and he talked about making sure that you use paste in sensors, and also made sure that everybody understood that, you know, it's important to make sure that your temperature settings are reading properly. So anytime you're commissioning or servicing a water-to-water unit, I feel that it's very important that you go ahead and check the aquastat setting and then compare that to the load out coming out of the unit. And when we refer back to the operating envelope diagram, we really only we never want to see water temperatures coming out of the heat pump that are above I say 105. They used to say 115, but at 105, you're going to make sure that even with a lower loop field temperature, that you're going to be operating the compressor in the safe zone. Sometimes I've seen where the temperature coming out of the heat pump is as much as 10 degrees higher than what the aquastat was set for. So we want to be careful of that. We want to, you know, maintain the integrity of the compressor, and we want to extend the life of the compressor. There's been times where I've seen aquastat set at 105, and the temperature of the water coming out of the unit was over 120. So we really want to be able to avoid that. How to change a hot deck tank to a demand tank, it's pretty simple. So this is just kind of a vanilla diagram, and the zone module on most hydronic systems have got a set of dry contacts that were put there to bring on the boiler. Since we don't have a boiler in our systems, we've got a heat pump. What we can do is we can break one leg of the aquastat that normally makes the call to the heat pump, and we can run it through that closed contact so that anytime there's a call for heat, the geo unit will run. If there's no call present, the heat pump will not run, even if the aquastat is calling for heat. So that's all I've got for today. I wish I had more time to go into this in a little more depth, but if anybody's got questions, perhaps we'll take a couple today. And of course, we can always be reached at Design Services. Thanks for attending. Carly, did we have any questions?
Nope, but if you guys came in late, we will be sending out this link via email later this afternoon that you can rewatch the rest of it. But nope, there were no other questions, Jim.
Okay. Well, thanks everybody for attending. And of course, if you've got more questions on this, if my explanation and my coughing today was confusing, please feel free to reach out to Design Services, and I will personally try to get back to anybody that needs clarification. Thanks everyone, and have a great day.